Yeah, so we're on page 16, and we're looking at subtraction. And this is the definition of subtraction. This is how you define subtraction when you're dealing with rational numbers. To subtract any rational number, add its opposite. So what did we talk about on Friday? Adding. So what are we going to do today? Add. You're like, wait, I thought subtract. Yep, we're going to subtract by adding. And maybe some of you are a little bit confused, but that's why we're going to go over some problems. Okay, the first problem we're going to go over is this one right here. Negative 2 1/10 minus negative 2/10. So go ahead and write this problem down. Do you guys remember a little process called stay, change, opposite? You guys remember that? Okay, in these problems, all these problems in this lesson, we're not going to look at this problem as a subtraction problem. We're going to change it to addition. And do you guys remember the different rules for addition? Same signs, add, different signs, subtract. We're going to be able to apply that today. And some of you, maybe a song is going through your head, and now it can't get out of your head. Hopefully. Oh, don't go out loud, guys, because then I get stuck in my head, and then I'm thinking about it all day. Okay. Stay, change, and then opposite. We're going to have to be able to go with that process on all these problems, because if we can make it an addition problem, man, it's really not that much difficult than what we did on Friday. Okay, so can somebody tell me how this would change from negative 2 1/10 minus negative 2/10? Stay, change, opposite. Drew, go ahead.
Negative 2 1/10 plus 0.2 or 0.2.
Mm-hmm. Okay, the first number stayed the exact same. Instead of subtraction, we changed it to addition. And what's the opposite of negative 2/10? Positive 2/10. Have we done this before, even in this class? Of course we have. So now we have two numbers being added, and they're different signs, so we're going to go through that process. But these answers should be reasonable to all of you when you work them out. You work them out, you get this answer, and that answer you get should be reasonable according to an estimate. I'm going to abbreviate here, an estimation. Now on your homework, some problems you're going to have to, it says estimate, then add or subtract. Then you need to do both parts. Some of them just say add or subtract. You can just add and subtract. But estimation is always a nice thing. What would negative 2 1/10 round to? To the nearest integer. Michelle? Negative 2. So that's what the first number rounds to. What does 2/10 round to? 0. Oh, so negative 2 plus 0? What is that going to give me? Negative 2. So that's my estimate. I'm going to keep that here because I'm going to compare if that even makes sense. Okay, when we have opposite signs being added, do you remember what we do? Yeah, you take the larger absolute value minus the lesser absolute value. So 2.1 minus 0.2. You subtract the two together, and what do you get? 1.9. And then which sign should it keep? Why a negative sign? Someone raise your hand and tell me, Alex. Yeah, this absolute value is larger for negative 2.1, so you keep its sign. It should be negative 1.9 or 1 9/10. Now, how does that look with my estimate? What do you guys think?
Close.
Very close. How close is it? Can someone raise your hand and tell me how close? Andrew?
Negative 1/10.
Okay, close. That's close. Not negative 1/10 away, just 1/10 away. It's 1/10 away from the estimate. So is that pretty close to each other? I would say that's pretty close. It makes sense. They're both negative. Okay. Any questions on that? All right, let's move on to the next one. The next one. That one. All right. Here we have 2 1/3 minus 1 1/4, and it says subtract. Okay, so pretty straightforward what to do. I want you guys to get used to writing these subtraction problems as addition problems. So somebody tell me what the state change opposite would look like on this problem. Sam?
So 2 1/3 plus negative 1 1/4.
Yep, 2 1/3 plus negative 1 1/4. Okay, just get comfortable doing that. I'm trying to give you tools, like you have that now tool. Change a subtraction problem to an addition problem. Sometimes you want to use that tool, and other times you're like, I'd rather do it the other way. And you have those two options. So we're just getting practice. Okay, I need an estimation here, so somebody tell me what I round both those numbers to. Let's go with Henry. What would I round 2 1/3 to? Nearest integer, 2. What would I round negative 1 1/4, Eva?
1.
Negative 1. And what's 2 plus negative 1? 1. Okay, that's my estimate. It's going to be 1. Okay, that sounds fine to me. That's just an estimate. Okay, when I'm adding two numbers with opposite signs, what do I do again? I take the... Oh, sorry. Before I get to that process, I take the larger absolute value and I subtract the lesser absolute value. So really what I'm doing is 2 1/3 minus 1 1/4. Mr. A, isn't that what you were doing at the beginning? Yes. But we're just going through this process. Okay. Can I, William, just subtract them like they are? Why not? Oh, those denominators. When you're adding or subtracting, what must be common? The denominator. What about multiplying and dividing? We haven't talked about that yet, but what about multiplying and dividing? Do you have to have common denominators? No. So don't stress out when you get to that point. What is the common denominator, or the LCD? Now, 12. So how do I make these denominators turn into 12? What do I multiply, William, the top fraction by? 4 over 4. Very nicely put. That gives me my 4/12. What do I multiply the bottom fraction by, Hudson? Good. 3 over 3. And that gets me my 3/12. Okay, nice. What is 4/12 minus 3/12? Drew? 1/12. And what's 2 minus 1? 1. Is my answer positive or negative? Somebody explain why. I think it's negative. I think it's positive. Well, it can't be both. So why, Gracie, is it positive?
You're subtracting the smaller number from the larger number, so and the larger number was positive, so
you keep the sign of the larger absolute value. Okay, what do you guys think? How far off is it? Raise your hand, Natalie. 1/12 away. So even less than the other problem that was 1/10 away, I believe. Okay, good. Makes sense? How many of you are... Mr. A, this is almost what we did on Friday, isn't it? All we have to do is state change opposites, and then we can work out a problem. And now Mr. A, because he's getting older and it's a Monday, he didn't get as many hours of sleep as he normally gets. I need some help up here. Do you have a question, Drew? Or do you want to help? No, you don't want to help? Oh, okay. I need, this time for every problem, I'm going to need 3 people. One person is going to convert it from a subtraction problem to an addition problem. That's all you do. You just convert it. State change opposite. The second person is going to estimate it using the state change opposite. So estimate the addition problem. And then the other person, last but certainly not least, is going to give me the actual work and the actual answer. Now, does that mean everyone else kind of just watches like you did yesterday watching that game? No. You have to work it out too, and then we compare our answers. So, state change opposite, Mary. And you can come up if you want, Mary, while I'm picking other people. I'll go with Andrew. You're going to do the estimate. And Josiah, you're going to do the actual. Thank you for volunteering, guys. Oh, go ahead, Mary. And wait, did I give you a number? Okay. You're going to do this problem right here. So can you do that for the state change opposite first? And then who is doing it? Andrew's going to do the estimate. When you're ready, you can come on up. And then Josiah, when you're ready, you can come work it. So you guys give me all those parts. I'm going to come around and see how you're doing with that. And then when those other 2 guys are ready, you can come up. Please show me the work. I don't want an answer. that doesn't help me to figure out what to do. So make sure you show your steps. You can bring your paper if you want. Okay, so 81 hundredths plus positive 3 and 19 hundredths. All right, good job with the state change opposite, Mary. All right, when you're ready. From her numbers, yep. So here we're getting it. And do it below, Andrew, her work, and then Josiah, you have that right side to work your problem out. Let's go. Yes.
Yeah, this is
Okay, so you can go work, Josiah, and I'll talk. So he did 81 hundredths is about 1. That's a good rounding. And 3 and 19 hundredths is about 3. And 1 plus 3 is 4. So let's see what happens here with this problem.
Do I have to show
Yeah. Show me that work. Oh, that work. My favorite part of the problem. And then just circle it. All right. Thank you. How many of you got either? You could have put 4.00 or you just put a 4. Either way is going to get, either one's the correct answer. How many of you got that for your actual? Wait. Sorry. How many got that for your, sorry. Is the estimate and the actual the same thing? Does that happen? Does it always happen? They just got to be close. And if, bless you, if you ask, are 4 and 4 pretty close to each other? They're very close. So that makes sense. How many of you got 4 as your actual? You got that? Okay. If you didn't get it, maybe I didn't give you enough time or something happened, but there's the work for you if you want to know what to do. Okay, 3 more volunteers. Yes, Hudson, you can do the state change. No? Oh, no? Okay, fine. I'll go with Jackson. You'll do, on the next problem, just a moment, you'll do the state change opposite. Darius will do the estimate. And Michelle will do the actual. Okay, so here's the next problem. Negative 11 twelfths minus negative 8 fifteenths. Take your time. Don't come rushing up here. I got the answer, and oh no. Oh, Jackson's ready for this, though. Oh my. Before I could even finish. Now, go ahead. So he's doing state change opposite, and hopefully you match up with what he's doing. And then the estimate, whoever's doing the estimate, you're going to do it off of his state change opposite. And then, Michelle, you can actually do the problem. Okay, negative 11 twelfths plus positive 8 fifteenths is correct. And below it, you can write the estimation with the rounding.
What is the LCD of 12 and 15?
What's your estimate? Well, what's your guess?
I don't know.
60. Did you do okay on that last problem? Okay, and then try this one out. This one's tough. And then, yeah, Michelle, whenever you're ready, you can go on up. And I'm checking your answers as I walk around. Please don't be sitting there doing nothing. All right, I see answers, but they're not all the same. So I wonder where that could be. This one's tough.
You have to be like both. So I do like this.
Do that problem.
That problem.
Yeah, so you want to get a common denominator. What's the LCD, guys, of 12 and 15? 60. I want to get both those fractions that have a denominator of 60. So I have to multiply both of them by 1 in different forms. So no pressure, Michelle, but Swivel's staring at you right now. This feels good, guys. Like, Swivel's on, I'm talking, but he's not looking at me. So I don't have to worry about how my hair looks or if that yogurt's still on my face from breakfast. I'm calm. Yeah.
So, negative is on the bottom because it's less than. So this is the bigger number because it's positive.
So yes, technically it is a bigger one, but when you're actually like getting that sum, you got to do 165 minus that, because that one technically has a greater absolute value. And then, oh my, Michelle, I saw that on other people's papers, but not all people's papers. Okay, how many of you are okay with the new fractions being negative 55 sixtieths and 32 sixtieths? Like that's what you rename them? Okay, and then you're like, but then what do you do from there? Okay, you have two numbers that are being added. One's negative, one's positive. So do you remember what you do when you're adding opposite signs? You subtract, and that's the subtraction. And you get 23 sixtieths, but is it positive or negative? Well, which one had the greater absolute value? The negative, so you get that. Oh, Mr. A, see, estimation doesn't work. What do you think? Is my estimate okay?
Yeah.
How far am I from 0? 23, and oh, did you hear that? 23 sixtieths. You're way off. Now remember with fractions, those are very small pieces. By the way, if you get a pizza and you get a 60th, sorry, you're not getting very much. But 23 sixtieths, man, that's a lot. Well, it's about 1/3 of that pizza, which is... Actually, guys, I'm very hungry right now. No, sorry. Okay, let's keep going. All right, how many of you got negative 23 sixtieths? How many of you, if you didn't get that, you understand what we had to do to get there? Like, even if you didn't get it, I added instead of subtracting, or I didn't keep the same sign, whatever the case is. Okay, estimate's good on that. Are they ready for this? It's possible. Actually, it's already up here. Go ahead and do this one right here. Do it on your own this time. And now I'll give you more. There's I think 1 or 2 more that you could do on the board, but you're doing this alone. It's by yourself. Sam? Okay, so work this one out. Do your state change opposite. Make it an addition problem, and don't forget the rules. Yes, sir.
So, I don't understand how you got 5 and 4.
Yeah, so when I was looking at your problem, or did you erase it?
I erased it because I didn't.
You just...
15 times.
Yeah, you multiplied this by 15 over 15, and that by 12 over 12.
Mm-hmm.
Yeah, so you could do that, but you're going to get these big numbers. So what you're trying to do is look at this and say, all right, what's the LCD of 12 and 15? What's the smallest number that both of these fit into? And here's the process I go through. Can they both fit into 15?
No.
No. And now I double that. 30? Can they both fit into 30?
No.
Can they both fit into 45? You see, I'm going up by 15. Can they go into 60?
Yes.
So then that's the magic number. I want these to be 60. So what do I multiply this to get 60? 4 fourths.
So essentially what you're doing is whatever, so this is even and this is odd. So you're taking the odd number and see what number it goes into that's even.
Kind of, yeah. You're thinking well about it. What I do is I take the bigger number, just the biggest number, and start seeing how many times do I have to multiply it so that both of them can fit, or all 3 of them can fit.
Could you do it that way to find the odd number
You could, but sometimes
even?
it's possible. Yes, that's possible. But I want to do it for everyone because sometimes you're going to get that big number again. It just makes it harder. Okay, let's see here. Hagen, change it. You don't have to get up here, but change it to state change opposite.
Negative 8.1 plus 4.33. Or negative.
Negative 8.1 plus negative 4.33. You guys get on state change opposite? Okay, Andrew, I'm adding 2 numbers with the same sign, so what do I do with those numbers? Yeah, I add those absolute values, so I should get 8.1 plus 4.33. What do I get when I add those 2 together, Alex?
12.43.
12.43, and the sign of that number should be, Josiah? Negative, because they were both negative to start with. That is correct. Negative 12 and 43 hundredths.
Okay, so I did it wrong and I subtracted instead, but I still got like an absolutely different answer.
So you subtracted these, and you got probably a lot smaller than that?
Yes.
Yeah, so if they have the same sign, right, they're both negative, and you're adding them, add those two values together. Same signs add, different signs subtract. And guys, you notice that, I don't know if you have a song for subtraction. Do you have a song for subtraction? Because, yeah, it's like it's a remix of the first one, and now the things are, wait, that sign, that sign. Listen, you only need to know the addition song. Because what can you make all subtraction problems into? Addition. So then just memorize that one, and you can perform it later for Swivel. You probably want to practice because it's going live after you do that. Okay. This is my last problem we'll do on the board, and my 3 volunteers. William, well, you can do the actual. I see those hands. Oh, I see that, Jack. You're do state change opposite. And then the estimate will be, who's not looking at me? That means I should pick on. It's funny. When I said that, everyone started looking at me. I don't want to be picked. This is the estimate. Eva, you will do the estimate. Okay, so here's the problem. Oops, that is not the problem. This one right here. Now, notice in this problem, what kind of numbers are you dealing with? Fractions or decimals? Both. Oh, no. What do? You can either make them both into decimals or both into fractions. Now, who's doing the state change opposite? Okay, Jack, you can come on up here if you want right away. Just do state change opposite. Don't convert anything. Who's doing the estimate? Who's doing the estimate? Okay, Eva, you're going to do the estimate in just a bit. And who's doing the actual? Who's the third person? William? William, please show us what you're doing when you work that through. All right. Negative 3/5 plus negative 4 6/10. All right, great. When you're ready, you can write the estimate. And you can use that one right there. And then, William, when you're set, you can come up here too. And you can do it on that right side. Yeah, bring up your paper if you want. Okay. That's okay. Yeah, take it slow, and you can look through your work as you write. One more problem that I'll do with you guys, but this is the last one we'll do up here.
Okay, so it's negative 3/5.
Oh, sorry. You can work it out. Let me explain this, and then I'll let you talk. So you keep working it out. All right. Negative 3/5 rounds to negative 1. I'm good with that. Negative 4 6/10 becomes negative 5. And then what's negative 1 plus negative 5? All right, that's my estimate, negative 6. So William here is going to see if we can get an actual that's hopefully pretty close. Okay, I'm going to check these as you guys are working them out. So I should see work. I should see stuff going on here. Oh my, already a variety of answers. I don't know if that's good or bad. Oh my, so close yet so far for some of these. So far in this section, you're very close, but you're going to say, oops, I didn't write that fraction correctly. I reduced it incorrectly. Or, where's my sign? If there needs to be a sign. What a great question. I think the easiest way, from what the other class said, maybe you'll disagree, but this is what I think. Just make them both into
Fractions.
I would say decimals. Make them both into decimals. But if you do into fractions, you'll be okay. If you do it correctly. All right. You're very close, William. Look at your estimate. Look at your estimate. Oh, very nice. All right. How many of you got negative 5 1/5? Okay. Your final answer should be either negative 5 1/5 or negative 5 2/10. tenths, the decimal version. Okay, good, William. Thank you very much. Now, how many of you maybe didn't get that answer, like either negative 5 and 1/5 or negative 5.2, but you were like really close? Anyone? No? Got point. Okay. Last problem we'll do together. And I'm going to call on people to help me out, but you don't have to come up here. Here we go. Uh-oh. 3 numbers. We're going to expand this to 3 numbers. Yeah, what a great question. What do we do? Okay, the other class, when I asked, what to do, they're like, wait, do you stay, change, opposite? Like, I don't know what to even do. There are 3 numbers being worked on here. And order of operations, you guys remember, please excuse my dear Aunt Sally, PEMDAS, whatever you call it. Okay, parentheses. We look at it here. Is there anything I could do to make this simpler, that negative 6 and 7/10? Can I make that simpler? No. Are there any exponents? Second step. Exponents? Any? Nope, we're done with second step. Third step, any multiplication or division at all? No, so we're done with the third step. We're on the last step, which is add or subtract left to right. So I look at this problem and I have to do this first. I'm going to deal with it first. So now I can do my stay, change, opposite. I'm just going to do it with those 2 numbers. I'm not dealing with that other number. I'm just going to take it one step at a time. Mr. A, can you do it all in one step? Yes, you can. Should you? Probably not. Just because it gets all these numbers and signs get mixed up. All right. Can somebody help me with this problem right here? 16 plus negative 9.82. We're adding, right? Opposite signs. What do we do with those absolute values? Subtract. The bigger minus the lesser. 16 is bigger than 9.82. So this is what we set up. And what do we get when we subtract these 2 here? Six and 1800ths. Is that positive or negative, though?
Positive.
Somebody tell me why it's positive. Jack?
The bigger number is positive.
Yeah, the bigger absolute value was 16. It had a positive. We'll keep it positive. So far, so good? All right. Now, what do you think I'm going to do with 6 and 1800ths and negative 6 and 7/10? Subtract them. Yeah, I'm going to write like this first so we know what happened. Okay. I did my first step. It's right here. So what do I do now? Stay, change, opposite again. So stay, change, opposite. Oh, that's nice. I have addition of 2 numbers with the same sign. What do I do with those absolute values? Add them. So I'm just adding here. And please make sure you add it correctly. If you don't line up place value, it does not work out very well. All right, what do I get? Ooh. 12 and 88 hundredths. So, problem with 3 numbers. Is it really that much more difficult? No. What do we have to? What order do we follow? What order do we follow when these problems? PEMDAS. Please excuse my dear Aunt Sally. Pigs eat more donuts at school. Whatever it takes for you to remember. That was from actually 2 years ago. Someone thought that up. And is it true that pigs eat more donuts at school? I don't know. Okay, anyway, your homework is going to be what page is first? Sorry. 15 to 16. 2 to 36. Even. So that means you're doing 2, 4, 6, 8, 10, 12, all the way to 36 even. And swivel. It's been fun today.
plus 1